In this video, I'll be explaining question 2 of homework 3. So we are given that x is uniform in the interval a to b and y is equal to x square. We need to draw the PDF and CDF of x, which is the probability density function and the cumulative distribution function. So since we are given that x is a uniform distribution, we can say that the PDF will be, for the interval a to b, it will be 1 upon b minus a, and it will be 0 in other cases. Now CDF, as we know, is the integral of PDF, so we can take the integral of the PDF from minus infinity to x, and since the interval is given as a to b, it will be integral of from minus infinity to a. On calculating, we get the value as x minus a upon b minus a. So the CDF can be represented as, for the interval a to b, it will be x minus a upon b minus a. For x less than equal to a, it will be 0, since it's not defined in the PDF is not defined in that interval. And for x greater than equal to b, it will be 1. This is because we know that the cumulative distribution function sums up to 1. Now we can see the plot for the PDF and the CDF. So for the PDF, from the equation we saw that for interval a to b, it's 1 upon b minus a, while 0 for other cases. And for the cumulative distribution function, we can see that in the interval a to b, it's given by this, whereas for b greater than equal to x greater than equal to b, it's 1, and for x less than equal to a, it's 0. Now moving on to part B. So here we are given that a is equal to minus 1 and b equals to 3. So we need to find and draw the PDF and CDF of y, and we need to also find the expectation of y. So again, we know that f of y will be given as p of y less than equal to y. Since y is given as x square, we can say this will be equal to p of x square less than equal to y, or it will be p of x less than equal to root y and greater than equal to minus root y. Now we can write this as the CDF of root y minus CDF of minus root y. And also we know that x can take values from minus 1 to 3, therefore y can take values from 0 to 9. So we will split the range of y into two parts. First, we'll consider the 0 to 1 range. In this case, x can range from minus 1 to 1, that is, x can take both positive and negative values. For the values of y 1 to 9, x can take the values 1 to 3, so here x will remain positive always. Now first we'll consider the range of 0 to 1. So from this equation, in this equation we can plug in the values of f of x equals to x minus a upon b minus a. This is what we calculated in part A, and so for root y it will be root y minus of minus 1 because a is minus 1 upon 4, which is b minus a. And similarly for minus root y we can compute this, and the value that we get in this interval of the CDF is root y by 2. Now considering the second interval, which is 1 to 9, again we can calculate the value of the CDF. And now here we know that in this interval x takes only positive values, so this won't be valid, and we will only consider this term. So for this case we get the CDF as root y plus 1 by 4, and for the other scenarios which is y is less than 0, the CDF will be 0, again by the same argument that the PDF is not valid in this range. And for y greater than 9 it will be 1, since the CDF sums up to 1. Now looking at the plot, we can see that this is the plot for the CDF, and in the interval y less than 0 the value is 0. For y between 0 and 1 it's root y by 2, and for y between 1 and 9 it's root y plus 1 by 4, and for y greater than 9 it's 1. Now we know that the PDF is the derivative of CDF with respect to y, so taking the derivative of these values we get the PDF as follows, and the plot looks like this. So here we can see that there is a discontinuity at y equals to 1. Now we will see the so we have to calculate the expectation of y. So this is given as summation of y into f of y. Now for the interval 0 to 1, f of y is 1 upon 4 root y, and in the interval 1 to 9 it's 1 upon 8 root y. So we will integrate over the two intervals, and the final value that we get after integration is 7 by 3.